Assalamualaikum warahmatullahi wabarakatuh, and welcome to our video assignment for MAT183 Calculus 1. In this video, we will talk about apply maximum and minimum problem. This video is prepared by CDCS 143 2D by Group 3. Before we move on towards our topic, let's get to know our group first. For our first group member is Muhammad Hanafi bin Muhammad Talha. For our second member, name is Muhammad Nurhaziq bin Muhammad Jamali. For our third member is Muhammad Ilyas Haikal bin Muhammad Faizal. And for our fourth member is me, Qishtina Balqis binti Burhanuddin. And lastly, our final member is Aisya Sofea binti Muhammad Shah Rizal.
Before we moving on to our main focus, which is applied minimum and maximum problems, I would like to share a bit about what is differentiation. Differentiation is a method of finding the derivative of a function. In maths, differentiation is used to find the instantaneous rate of change in a function based on one of its variables. There are 5 applications of differentiation. The first one is related rates. The second one is analysis of function 1. The third one, analysis of function 2. The fourth one, the Rolle's theorem and mean value. And the last one, applied maximum and minimum problems, which is our main focus today. Finding maximum or minimum values is called optimization. So, apply maximum and minimum problems, basically, it is used to determine the highest and lowest point of the curve in a graph, or known as turning point. For example, we are attempting to maximize a company's profit, minimize expenses, or locate the least quantity of material required to manufacture a specific product. Here are 3 steps on how to solve maximum and minimum problems. The first step is find the derivative dy over dx. The second step is let the derivative equal to 0 and find the values of the variables. Dy over dx equals to 0. And the last step is second derivative test, d2y over dx2. If d2y over dx2 is greater than 0, that means it is a minimum value. When d2y over dx2 is less than 0, that means it is a maximum value.
So let's move to the main topic, which is problem statement and problem solution. A closed cylindrical container of radius r/cm and height h/cm is to be made to hold 5,000 cm3 of liquid. Hint: V equals to pi r squared h, A equals to 2 pi r squared plus 2 pi r h. So for the first question, my friend Aisya Sofea will present about it. Show that the surface area of the container is 2 pi r squared plus 1000 over r. And for the second question, my friend Haziq will present about it. Find the value of r and h that minimize the total surface area of the container. And for the third one, me myself will present about it. Find the minimum surface area of the container.
Moving on to the problem solution section. For the first question, it requires us to show that the surface area of the container is equal to 2 pi r squared plus 1000 over r. In the previous statement, it's already stated that the container is cylinder shaped and the volume is equal to 500. There were 2 formulas given, which were volume equals to pi r squared h and surface area equals to 2 pi r squared plus 2 pi r h. So how are these 2 surface area formulas are the same? So we move on to the solution for this question. For the first step, we need to write down the volume of the container, which was pi r squared h equals to 500. And we need to express that h is equals to 500 over pi r squared. So the next step, we need to compare the formula with the given question. Surface area equals to 2 pi r squared plus 2 pi r h. The value of h is, we need to substitute the value that we find out just now. So A is equals to 2 pi r squared plus 2 pi r, the value of H, which was 500 over pi r squared. So we need to cancel off what was in the formula. Pi cancel off with the pi in the bracket, r cancel off with the r in the bracket. So what was left off was 2 pi r squared plus 2 times 500 is equals to 1000 over r. So this is the solution for this question.
Okay, for the question 2, the question asking us to find the value of R and H that minimize the total surface area of the container. So, from this question, we need to know the keyword. So, the keyword first is find the value of R. Find the value of R. H. Then minimize the total surface. Okay, for this equation we have 3 steps to solve the problem. So let's go to the first step. Okay, step 1, we need to find the derivative of the surface area. From the equation 1, we know the surface area is equal to 2 pi r square plus 1000 over r, or you can write like this. After that, we need to derivative a with respect to r. So dAdr equal to 4 pi r minus 1000 over r square, or you can write like this. So done for the step 1. So step 2, we need to let derivative equal to 0. So dAdr equal to 0, and we got the equation 4 pi r minus 1000 over r square equal to 0. After we get the equation, we need to solve the equation to find the value of r, and we get r equal to 4.3012. So done for the step 2. Okay, let's go to the final step, step 3. Okay, step 3, we need to do second derivative test. So first, what we need to do is we derive second derivative on dAdr, and we get d2a over d2r equal to 4 pi plus 2000 over r cubed. So let's just, then we enter the value of r, which is 4.3012 into the second derivative that we do, like this. Then we solve the equation and we get 37.70. For the remember, if the value of second derivative is higher, is greater than 0, is a minimum value, while if the value of second derivative is less than 0, is a maximum value. So for this equation, the second derivative is greater than 0, so is a minimum value. So r is a minimum value when r equal to 4.3012. Then we find the value of h, and we get h equal to 8.6028. So done for question 3.
So let's moving on to the third question. Find the minimum surface area of the container. So for this question, what we're gonna do is just substitute the value of r. From the previous question, we got that the value of r is equals to 4.3012. So just substitute into the formula 2 pi times 4.3012 squared plus 1000 over 4.3012. So we get the answer is 348.7342 cm squared. So that's all for the problem solution.
The conclusion for this video are apply maximum and minimum problems are related with the concept of application of differentiation. Therefore, identifying the right formula and finding the right derivative will lead to the right answer.
I think that's all from us. Thank you for your attention and time. Until we meet again, bye!